The halogens form the seventh group in the periodic table, located just before the inert noble gases. The halogens are the most toxic and reactive of the non-metal elements. Each halogen has a distinctive color, getting darker as you move down the group. They are also poor conductors and have low melting and boiling points. Fluorine is a highly toxic pale yellow gas. It is the most electronegative and reactive of all the elements in the periodic table, and can even form compounds with the noble gases. Because of its immense reactivity, it is difficult to isolate and store in its pure form. Chlorine is a yellowish-green gas that combines with nearly all elements. We use chlorine's high water solubility to our advantage by adding it to drinking water to kill harmful bacteria. Bromine is the only non-metallic element that is a liquid at room temperature. It is isolated from seawater for industrial use. It is a brown, noxious, and heavy liquid that is highly corrosive to human flesh, causing sores when exposed to skin. Iodine is a shiny bluish-black solid. Heating iodine to just over room temperature causes it to spontaneously sublime, meaning that it changes directly from a solid into a gas. Iodine readily reacts with most elements in the periodic table, but it will be displaced from its compounds by any of the lighter and more reactive halogens. Astatine is the only radioactive element of the halogen group. The longest half-life recorded for this element is just over 8 hours. Astatine has a metallic appearance and is semi-metallic in nature. The halogens are typical nonmetals with relatively low melting and boiling points. The melting and boiling points increase steadily going down the group. Fluorine and chlorine are gases at room temperature. Bromine is a reddish-brown liquid, and iodine and astatine are solids. Halogens readily combine with hydrogen to form hydrogen halides. These covalent compounds quickly dissolve in water to form extremely strong acids. Hydrogen fluoride is used to strip solid gold from circuit boards. The human body uses the super strength of hydrochloric acid to break down anything in the stomach. Looking at the periodic table can help explain the reactivity of the halogens. Here, the elements are listed in order of their atomic number, which represents the number of protons in an element's nucleus. In its normal, or ground state, this nucleus is also surrounded by an equal number of electrons. And as the atomic number increases, so does the size and mass of the atoms. In the periodic table, each horizontal line is called a period, and it represents the number of electron shells normally possessed by the element's atoms. For example, there are 4 electron shells in an atom of bromine, so it lies in period 4. Meanwhile, an atom of astatine in period 6 has 6 electron shells. As you read across the table from left to right, the vertical lines of elements are called groups. Elements in a group have the same number of electrons in their outermost electron shells. These are called valence electrons, and they dictate how elements interact. Elements in the same group generally interact with other elements in similar ways. None of the elements greater than atomic number 83 are completely stable. Astatine, with an atomic number of 85, is the only radioactive element in the group. Halogen comes from the ancient Greek halo, meaning salt, and genes, meaning former. Minerals containing chlorine and bromine are found naturally in rock and sea salt. The halogens all have 7 valence electrons, so all the elements in the group have similar chemical properties. Almost all atoms need 8 electrons in their valence shell to be stable. Because they only need 1 more electron to have a complete valence shell, the halogens are extremely electronegative and very reactive. As you move down the group from fluorine to astatine, each element is less reactive than the one before it. This occurs because the attractive force of the positive nucleus becomes weaker as it is blocked by an increasing number of electron shells.